the 3D printers that we work with. So I'm the one who thought of this session because the 3D printing use in the injection molding industry is really gaining some momentum. So what I hope to do is give you guys a general overview on why, when, and how the Polyjet technology specifically, and I'll go over what that is, what the Polyjet technology can do for injection molded parts, because this really flips the thought process that a lot of people have for 3D printing around. A lot of people think that 3D printing is going to give you the end product, like you're going to print the part itself, and that is true. A lot of people do that, but we can also use the 3D printing technology for plastic parts to actually print the mold. And so we're going to talk about printing the mold, how and why that's different than how we do it now, why that's good, the advantages of it, the limitations of it, in just broad terms. So like I said, we're going to go over the why, the when, and the how to use these, and hopefully at the end of it you'll have a good idea of how this might be incorporated into your company and your systems. So let's start with the why. There's really a handful of reasons of why customers are starting to do this with their 3D printing, printing the molds themselves. Most of it is obviously the faster, better, quicker, cheaper type of stuff. Historically, in the printing or the production life cycle of your parts, your models, your assemblies, whatever you're creating at the end of the day, the testing of it is at the end, which is timely, costly, all of those types of things that people like to avoid. So people started using 3D printing into the design process earlier. Really a couple years ago, it started to catch on quite well. But what this allows you to do is start to build iterations of your molds earlier. And this is out of plastic, not the traditional metal that most people are used to seeing. And again, there's some big advantages of that, but there's also some limitations. So one of the bigger advantages is this one, to test your design. So what you're allowed or able to do is print the mold. As you can see, the molds are the green parts in these pictures you're looking at here. And you can use the end-use plastic that you want. So the polystyrene, the polyethylene, the ABS, those types of plastics that you're actually going to be using for your end-use product, as long as the mold temperature is below, let's say, 300 degrees C, you use that plastic into your mold that you 3D printed versus the traditional milling, wire EDM, those types of things out of aluminum or steel. So you print the mold itself and then inject the plastic that you're going to be using in your end-use product, and you can go through iterations of this significantly faster than you could with traditional manufacturing methods. So testing your design early in the design process with the true plastic that you're going to use for the end-use product is a big advantage for a lot of people. I already mentioned this one as well, saving time. It takes a long time to get a metal mold made. It's time-consuming, weeks to months. It's very expensive. Those types of things can be significantly reduced by printing the mold. In this case, you're looking here at mold inserts out of the plastic. So these are the pieces we're talking about here, these green pieces. It's a product called digital ABS in the Polyjet world. It has pretty good temperature and mechanical properties, and those are the parts that we will talk about printing. And then of course you inject your plastic into it. You can still see a gate and runner here attached to this little plastic injection molded piece here. So saves you a lot of time during the design aspect of it. All right, so along with that, we already mentioned this as well, reducing the costs it is expensive to machine out of aluminum or steel, especially with some molds that are very, very complex, tens, hundreds of thousands of dollars, weeks to months of lead time. And so it could be a significant increase in your output by printing these cores and cavities in the digital ABS material. So another good advantage of it. And this is one that a lot of people may not think about, but the confidentiality of it is also is helpful. You are a self-contained unit at this point. You don't have to send out your ideas, your design ideas, your intellectual property. You can keep that in-house, print it out, do the testing that you need, and then move on from there. Now, if you're going to print out a lot of pieces, it may be best to, at the end, still make the mold out of metal. There's a lot of advantages for that. But again, at the design or testing phase, an injection molded, 3D printed injection mold may be very, very helpful. Also, if your run quantities are going to be 30, 40, 50, 60, something like that, you can get by with just using a 3D printed mold. Once you get into thousands and tens of thousands or millions, the plastic mold just doesn't have the mechanical properties that a metal mold would. And you would still take the time, energy, and effort to have that printed in metal. But again, as a transition step or a testing step, printing this out in plastic, the digital ABS material I mentioned, is a significant improvement for a lot of people. So that's the why you would do it: to save time, to save money, to save cost, and then of course maybe the potential confidentiality piece of it. So let's go into the when to use it, because it's not for everybody. All right, so since you are injecting a heated plastic into another plastic, you can't treat the metal mold or the plastic molds the same way you would treat a metal mold. So the presses that you would need for this are smaller than you might traditionally use for a metal mold, but a 400 to 200 ton press is plenty. So if you already are using something like this, you understand what I'm saying. But you wouldn't need a 500 ton press or something even larger, because the plastic mold just couldn't handle those types of pressures. The material properties just aren't that good. So those would be some of the reasons. Here's some of the plastics that are good for injecting into a digital ABS mold. So your polyethylenes, your polypropylenes, your ABSs, some of your nylons, your polyamides, your nylons are okay. You can get into some of the glass-filled resins. As you see over the graph here, here's the quantity versus the type of plastic. So if you get into, let's say, a glass-filled nylon right here, that's the C category, you can see you're only going to get maybe 10 shots out of a mold before the mold is warped, broken, something to that effect. So, the polyethylenes, polypropylenes, polystyrenes, those kinds of easy flowability plastics, when they're melted, are good candidates for this process. Also, the part size that you're shooting needs to be a small to medium-sized part, because again, the pressures and the temperatures that the digital ABS material would take aren't as strong or as powerful that a metal mold might get. Someone asked about getting a printed version of this meeting, the PowerPoint, as well as the actual audio of this. We do record all that, so it will be archived for you. Dana, you'll get an email with that information as well. So you don't have to worry about writing all this stuff down. But again, these are the types of plastics that you want to think about using inside of the the 3D printed mold. So those are good candidates. Polyethylenes, polypropylenes, polystyrenes, ABSs are all good. You get good accuracy. You can get low volumes, 20, 30, 40, 50 parts, and we'll go through some of the details of those here next. So when you're printing your mold, these are some of the normal considerations that you're looking at when you're building a mold, whether that's in metal or plastic. All right, so let's go through some of these steps and how they are different and or the same for plastic injection molding. So the typical injection molding machine, right, it's got the raw plastic, it's got the heaters, it's got the lead screw, it's got the nozzle, the sprue, here's your A and B side here, your clamping unit. All of that's the same. What most people do successfully is they print the mold as on the backing plates here. So they leave as inserts. So they leave the metal backing plates in. They put the inserts in here. Obviously, the molten plastic moves through the screw. Then it gets pressed or injected into your mold, which happens right here. And then your A and B side of the mold separate, whether you use injector pins or not, and you end up with your end part. So the process is identical, but you're using plastic as the mold material versus a traditional metal. Now, one thing is interesting here is when you see, let me scoot up here. So when you're looking at here is the core and cavity side here. This is a fairly complex mold. You can see all of the all of the nooks and crannies, for lack of a better term here. You can see it's just bolted into the mold it's as an insert. So there's several advantages with doing that. One is as this plastic wears out, you just reprint a new one or a new iteration of this core and cavity plate. The other thing is this particular one doesn't have any, if you look close, maybe you can see you can put injector pins in here. You can put metal inserts into it. So if there's any particular high wear areas, the digital ABS material does lend itself quite well to machining or putting in these metal inserts. So if you find that it works pretty well, but there's a little bit more strength or temperature resistance or something like that you may need, you may think about putting a little metal insert into that. The gating is also pretty similar. It works real well with the standard sprue gate. Those are the most common, just directly injected into, so the material would come through here, and you can see here's the part in here it's being created. So the gating would be just punch it right through, pretty high pressure, slow time frame from that standpoint, and it would fill in your cavity here. You can also work with fan gates. This is the fan gate area in here, so you can see it fans out. Those lend themselves fairly well to 3D printed injection molds. An edge gate also works out fairly well. What I have seen here, though, is people will put a metal insert here, because what will happen is as you're applying the pressure and the temperature, this is the weak area. This will crack or break or something like that. So if you use edge gates often, what I've seen done the majority of the time is they'll have a little metal insert in here that just reinforces this area. So a nice combination of having the speed, the ease of use, the design changes, all those nice things that you get with being able to print this part out, and then you add in the mechanical properties of the metal, and it works pretty well. You can also use tunnel gating. I haven't seen anyone do this yet. I've seen results of this. It seems to work pretty well, but again, just another type of gating for the injection molding. Venting, you got to have venting, or the air will, as you're pushing the plastic into the mold, air has to escape somehow if you don't put some venting into it. And you'll know fast enough, as soon as you push the plastic in, you'll build up a lot of pressure and it will just blow out the back of the mold or something to that effect if you don't put any venting. These venting rules are the same for metal and plastic, so just make sure that you put some venting in there. So if you're already doing injection molding, you know exactly what I'm talking about. the design rules for 3D printed injection molds are similar. The only thing I would say here is that you do want to continue along with the draft on your injection molded parts so that you can eject them from the mold. I would say, this says 1 degree here on this slide. I've seen 3 to 5 be a better number of degrees in draft for easily getting the part out of the mold without causing a lot of extra stresses in the ejection process of it. So, you've already shot the part and now you're pulled the A and B side apart. Now you got to get that part out. Without proper draft, it won't come out of the mold, and it will be a bad part, or in the case of a plastic mold like this, you can actually damage the mold as well. So, draft says 1 degree. I would really go 3 to 5 if your design will take it, but you definitely continue the draft process that you're used to. For the small features here, there is a height ratio to thickness that I would recommend, but again, just realize the advantage of printing this core plate out right here is that the intricacies of this are printed. They're not machined, so they don't cost any more time, energy, and effort because it has to print this piece anyway. So, in a machining standpoint, it's very expensive and time consuming to do this. From a printing standpoint, that's really one of the big advantages, is that the geometry is much more flexible and forgiving in 3D printing because you can change it as quickly and easily as you want. But there are some considerations here. It's not as strong again, so really tall, thin pieces, you just don't have the mechanical strength with a plastic injection mold that you would with a metal. But there's definitely some advantages there. And like I said, you would probably want to put a metal insert in here if you had something that was really tall and really thin that would break. So again, you would put some screws or some pins in here or something to keep pieces that were too tall and thin out there. So it would be basically a hybrid mold, some plastic, some metal. This is just a quick little chart to talk about temperature versus pressure. You probably know if you don't have enough pressure in there, you get what's called a short shot, which means your part doesn't fill properly. So it would look like this. See the little nooks and crannies out of the band for this fan blade? That's a short shot. The material didn't have enough pressure or enough time to fill all the voids in the mold. That could be a problem. Another problem could be if you have too much pressure, you get what's called flashing. So if you look at this picture here along the inner piece of the hub, you have extra material here. So if you've ever bought a model plane or something like that, there's little bits of material on the outside of the part you actually use or need. That's called flashing. So the part that the 3D printing sits very well in is medium pressure, medium temperature. Not enough pressure that you would create a lot of flash. Certainly it can take a pressure to fill the mold properly and not create short shots. But this is just a pictorial of this is where we fit real well in from a printing standpoint. And then cooling. That's the last piece here. Again, a plastic mold does not have the same properties that a metal mold does, and that's very apparent in the cooling process because metal conducts heat, right? So the heat can dissipate out of your part a lot faster in a metal mold than a plastic injection or a plastic printed mold. So you have to come out with secondary cooling, and what most people use is compressed air. So they'll take their shop air and they'll just blow it across the mold, for 10, 15, 20 seconds. That will cool the part off, and then they can pull it off or use injector pins or something like that. But you need to expect the fact that the part won't cool the same way it would in a metal mold. So those are something that you would want to keep in mind as well. But again, historically or traditionally, all of these pieces, these inserts here would be machined, and we're giving the ability to, we're creating you guys to have the ability to do some testing or some low-run production molding with some technology that you may not have been thinking about, because printing in a stereotypical type of way, you're printing the part that's being used at the end result. You're printing the end result. Here we're actually printing the process to get you the end result, and a lot of people aren't thinking of it in that way, and there's a lot of benefits to that. So that is a real brief, there's my 25-minute overview of how customers of ours are using this technology to help their design processes, design cycles, those types of things, and with a good deal of success. It is a design process. This company, Worrell, I've been to their facility. It takes a little bit of patience to try this out, because your gates need to be a little bit bigger, and runners that need to be sized a little bit differently. But if you're open to a little bit of investment in your time, and willing to change your thought process a little bit on how metal reacts differently to plastic, there's a lot of benefits to this, and companies are really starting to reap that. So again, in a quick 25-minute overview, that's the way you could potentially be using 3D printing to create the molds for injection molding. So I've only gotten one question, and that was about getting the printed version of this or an audio version of this. Now is a good time to open those up, and there's my contact information. Feel free to shoot me an email or give me a phone call. But again, I hope it was helpful to you, give you an idea, maybe spark some ideas on how you guys might be able to take some technology maybe you already own, or if you're investigating technology, another use that you could have in-house with the purchase of a printer. But again, this is Polyjet technology. Just a real quick review on that. Polyjet technology takes a UV light and a resin, and it uses UV light to cure the photopolymer. So there's several different types of technologies out there, but the reason Polyjet is most commonly used with injection molding is because it has a very fine resolution, and for that resolution you can get pretty good material properties. So those would be the types of things that it has a good resolution versus mechanical properties. That's why Polyjet is the most common used technology for this, for 3D printing the injection molds. Okay, so I was told not to go long. So do you, anyone else got any questions for me?
Now's your time to get them answered. And also, Tom, to your question about where you can get, if you can get a printed version, we do record all of our webinars, and you can access them through our website, trimexsolutions.com. At the upper right-hand corner there, you will see our Facebook and Twitter accounts there, and also our YouTube account. Just click on that, and all of our webinars will pop up. It's really easy. All right, any other questions?
And I'll just say this too, just because injection, there's tens and hundreds of different materials and machines. I showed you a horizontal injection molding machine, but they have vertical ones. Does it work with vertical? There's a huge range of questions that could go along with this topic. But as you get into more specific questions, please reach out to us. We'll be glad to help you out. And if I don't know the answer, I'll certainly be glad to find that for you. But I hope it was helpful in sparking some thoughts and ideas for you.
All right, we'll wait here just a little longer to see if we do have any questions come through. Kelly, you did such a fabulous job that you've answered all their questions.
Yeah, I saw that. I wish that were the case, but I'll take a little compliment every now and then. So thank you very much.
All right. Well, it doesn't look like there's any questions. I just want to thank you all for joining us this afternoon, and I hope you have a wonderful rest of your day. Goodbye.
Thanks, guys. All right, bye.